Welcome back. In this video, we are going to continue our exploration and exploratory data analysis, and we're going to consider how to plot data on a single quantitative variable. What you will need for this video to follow along and understand how to execute the commands in StatCrunch is the data set called F16 that we discussed in video 0. So pause the video now, go ahead and open up that data set in StatCrunch. So to briefly review, exploratory data analysis is a process that we carry out with any data set. And in video 0, where we introduced the data set F16, we reviewed what quantitative variables are, what exploratory data analysis is, and how those two work together when we're working with a quantitative variable. In other words, what is their purpose? In the last video, we talked about how to inspect data values. And now we're to the point where we're going to talk about how to plot the data. We're going to see that quantitative data is considerably more difficult to analyze than categorical. And unlike categorical, where we were always plotting the same thing no matter what sort of method we were using, whether it was a pie plot, a Pareto, or a frequency bar plot. We were just plotting frequencies or counts in different ways. We're going to find out that with quantitative data, the different plots that we're making are qualitatively different, and they're capturing different aspects of the data. In the last video, we're going to come back to plots when we put together all the information we have, and we're going to talk about the three things that we get visually from the plot, which is the shape, the number of modes, and the outliers. But we'll come back to that later. So let's look at the various methods for plotting variables in StatCrunch when they're quantitative. The way that we always graph any data in StatCrunch is we go to the main menu bar and we click on the Graph tab. And you'll see a very large number of different options here. We're going to focus just on three: the histogram, the box plot, and the dot plot. And I'm going to go through each of these plots separately, talk about what it is they do, and how we actually compute and create those plots in StatCrunch. What I want to do first, when we're looking at the initial plot called a dot plot, is I want to look at this variable in the F16 data set called number of changes. So we remember that each year the Air Force made a certain number of changes to the cockpits. And I want to go ahead and I want to look at all of that data graphically and kind of all together. So what I'm going to do is I'm going to count the number of years where I had 0 modifications, count the number of years where I had 1 modification, 2, and 3. And what we're going to do then is we're going to go ahead and just plot those values on a number line. So I'm going to take each year and make it a dot. And this is going to give us what we call a dot plot. So first, let's see how to do this in StatCrunch, and then we'll see how it actually looks. So everything here is very straightforward, just like we said before. And I'm going to follow along. So here's my data, graph, and dot plot. Feel free as you're watching the video to stop it and review the PowerPoints. There are some details that people will occasionally miss. I click on this and a new window pops up. And we notice there's a lot of different options, a lot we can do here. So let's try to unpack this particular window. So first of all, we're going to choose the variable that we want to plot. So I'm going to go ahead and click on changes, and you can see that's going to highlight that variable. So I have to tell StatCrunch first, what do I want to plot? And then we're going to go ahead and we're going to put in the axis and the title. And this is all we really need to do. If we wanted to, we could change the size of the dots. Okay, there are some options for that. If we had a categorical variable along with a quantitative, we could group by the values of the categorical variable. And if we had multiple dot plots, okay, we could go ahead and kind of format how they're displayed on the page. And you hit compute. And we should get something that looks like this. Notice that it's a little difficult to read this, right? Because there's no scale on the frequency axis. But we can see that how many years did we have just one cockpit modification? We'd count the number of dots, right? 1, 2, 3, 4, 5, 6, 7, 8 years we had one modification. So I'm going to go ahead and do this in StatCrunch, and you can kind of follow along. So first I want to highlight changes. X is going to be the number of changes made. And the y-axis will be frequency, even though it doesn't give units, right? And we have to give it a title. So we could say something like distribution of yearly cockpit changes made to F-16s. And I could put the range of years if I wanted to. I believe the last year is 2016. And then we can go ahead and hit compute. And there we are. A really important thing to keep in mind when you're plotting any sort of data, this doesn't just apply to dot plots, you always want to make sure that your plot is self-explanatory. It should be standalone. In other words, a person should be able to look at your plot and understand what they're looking at without having to refer to any text or any outside sources. Sometimes that's difficult. The thing that helps is a really good title. And so titles might be a little on the longish side, but it's better that they're long and the person understand what they're looking at than they're too brief and the person be confused, because that's what you don't want. You want it to be easy on your reader. And so this is a dot plot. The only time we use dot plots is when we have small data sets. And you can see why. Okay, quantitatively, it's hard to really describe this plot, partly because there's no scale on the y-axis. And we're generally not going to work with data sets that are that small. Okay, so here we have how many data points? We have 31 data points. Usually when you get around 20 some data points or less, you would use a dot plot. 31, I probably would not use a dot plot. It wouldn't be advised. But I want to show you how to be able to make all three plots with all different methods so that you can kind of compare them yourself and see which is better. All right, moving along. We're going to look at our second plot, which we're going to call a box plot. Notice that the dot plot, in a sense, is a high-resolution picture. When I'm looking at the dot plot, I'm literally seeing every single data value. This is the highest resolution sort of picture of the data that I can make. Now we want to go to the other end, and we want to look at the lowest resolution picture. That's called a box plot. And the box plot is essentially a graph of 5 numbers from the data set. So we're going to compute the maximum value and the minimum value We get those just by sorting the data set. And then we're going to compute the quartiles of a data set, which you may or may not be too familiar with. The third quartile, the second quartile, and the first quartile. And we're going to plot these 5 numbers. And we're going to see what that looks like. So if we look at the number of accidents, I'm going to switch gears now. Instead of looking at number of cockpit changes, let's look at the number of accidents. That was the other variable in the F-16 data set. And what I'm going to do is I'm going to order the data values. So it's going from the smallest data value. We had a year where there was 0, all the way up to the highest. We had a year where there were 23 accidents. And what I'm going to do first is find the median. The median in statistics is exactly the same as it is in real life. When you're on the highway and there's a median, what does the median do? It splits the highway into 2 equal parts. The median of a data set does the same thing. It is, in a sense, the middle data value for a sorted data set. So we can see here that we have 31 values. So our middle value would be the 16th. And therefore, our median would be 9. The median is also called the second quartile, or the 50th percentile, because 50% of the data lies below it, or two quarters, right? 50 cents is 2 quarters. 2 quarters of the data lie below it. Now we want to find the other 2 quartiles. So the first quartile is the 25th percentile. And all we do is we now consider the lower half of the data set. And I will mention that there is ambiguity as to whether or not this lower half should include the median or not. And so if you start to get into the technical details, if you go to compute it in Excel, for example, there are 2 different types of medians. 2 different types of quartiles. One quartile that includes the median and one that doesn't. We're going to use the one that does not include the median. So this blue box is now the lower half of the data. And if this is the lower 50%, the 25th percentile should be the middle of the lower half. And sure enough, if we have 15 data values, the 8th data value will be the middle of the lower half of the data. And that'll be the first quartile, or Q1. And of course, when we want to find the third quartile, it's the same game. It's the 75th percentile, or 3 quarters. So now I'm going to look at the upper half of the data, and I'm going to choose the middle data value for the upper half. And so our third quartile, denoted by Q3, is equal to 14. It's important also to remember that the quartiles are not the number of the data value in an ordered list, okay? So it isn't 8. It's just saying this is the 8th value, but the quartile itself is the data value that occupies the 8th place in that list. So let's see how a box plot works now. So what we're going to do first is we're going to set up something called a 5-number summary. These are 5 numbers that summarize a great deal of the information in the data set. The minimum and the maximum data values, of course, we can pick off from a sorted data set. They aren't particularly difficult. And this is the data set that we just worked with in the previous slide, so we know what those values for the quartiles were. And now the box plot is going to be a graphical display of these 5 numbers. So in a box plot, the data values here are on the x-axis. And we're really plotting, in a sense, the value of certain cutoff points. So the box plot consists of the 3 quartiles. So these 3 middle values comprise the box. Q1 is 5. So the end of the box is here at 5. Q2, or the median, is at 9. That's the bar in the middle of the box. Well, not necessarily in the middle, but it's the bar in the interior of the box. And Q3 is 14, and that's the edge of our box. Now, these things sticking out from the boxes are sometimes called whiskers. They kind of look like the whiskers of a cat. And very often they extend from the edge of the box to the extreme value in the data set. So this would extend from the third quartile all the way to the largest. And this whisker would extend from Q1, the first quartile, to the smallest. This picture, however, is not complete because it leaves out one detail, albeit an important one, which is outliers. So let me show you how outliers are computed for a box plot and how they're displayed graphically. So first of all, we draw a number line. We draw our box just like before. And what we're going to do now is we're going to compute what we call a fence length. So we're going to start off, first of all, computing what we call the interquartile range. So it's the range between, inter means between quartiles. Or in other words, it's the length of the box. And we're going to compute something called a fence length, which is going to be 1.5 times the box length. And from that fence length, we're going to create a kind of like a little region here that's going to contain all the non-outlier points. So Q3 to the upper fence length, this is going to be where all the data values that are non-outliers can be. So the upper fence length and the lower fence length are kind of like the boundaries for the outliers. It says that if a data point goes more than 1.5 times the box length outside the box, it'll be considered an outlier. And so similarly, this is the lower fence length, 1.5 times the box length below the first quartile. And this is going to be the boundary for lower outliers. And so now what we're going to do is we're going to plot the most extreme values within the fence lengths. And that's going to comprise the whisker. So in this particular scenario, this would be the largest data value within the upper fence length. And this would be the smallest data value within the fence length. But notice, this is not necessarily the lowest and the largest data value in our whole data set. These are just the largest and the smallest data values within these fence lengths. And of course, we go ahead and connect those up to the box, and that's how we get our whiskers. Now, the outliers are going to be points that lie outside these fence lengths. So here I have no lower outliers. There are no outliers below the lower limit, but we do have one upper outlier. And the way we generally visualize outliers is there's some sort of marker, and it'll be obvious because it'll be an isolated point. So here they put a little asterisk, or it may be a circle or a box or whatever. When we finally look at our plot, we don't actually include the fence lengths. We just compute them. And so our final plot would look something like this. Now let's see how to do this using StatCrunch. So if we go back here, I'm going to go to accidents. And what I'm going to do really quick is I'm going to make a dot plot of accidents. Let's go ahead and look at how accidents can be represented with these 3 different plots. So really quick, let's go ahead and make a dot plot, piece of cake, right? I'm not going to worry about the title and everything, all right? So number of accidents. And there's what the dot plot looks like. And you can see when you have a lot of different values, a dot plot really is not that informative. this would be incredibly hard to describe. Let's make the corresponding box plot now. So I'm going to go up to Graph, click on Box Plot, the variable that I want to plot. And here it's asking you how you want to display the data. So I'm going to use the fences to identify outliers. Okay, I want to do that. I definitely want to be able to know if data values are potentially outliers, just in case I would have missed something myself. And I'm going to draw the box horizontally. If you don't click this box, it'll draw the box plot up and down. You can put the mean and the median in. You don't have to put the median in because the median's already on the box. In fact, I won't put that in. And now we're ready. And that's all we have to do. So all you really have to do is just click the variable and make sure that this is checked. And really, that's all you have to do. And this is the box plot. So these are two representations of the same data set, pretty much on the same scale. All right. And when you hover over it, you'll see it tells you about Q1. Actually, it tells you about the whole data set, right? Number of data values, what the interquartile range is, the lower limit, the upper limit, and so on. And I accidentally highlighted those data values. I didn't want to do that. Let me go back and unhighlight them. This is actually a nice feature of StatCrunch, though. If I want to look at a specific data value, I click on its row and it gets highlighted in the plot, but I don't want to do that right now. Okay, and there we are. And of course, I would put an appropriate title in. Okay, so now on to our last plot, which is called a histogram. Generally, when we make a plot, the histogram is the one that we choose. So the dot plot generally has too much detail. The box plot is a really low resolution picture. It usually doesn't have enough detail. And the histogram tends to be about right. Because usually, remember what we're interested in. We're interested in that distribution of the population values. We want to have that nice smooth curve fitting through there. So let's see what's going on with the histogram here. So here I've taken this same data set. This is number of accidents. And what we're going to do, instead of doing what we did in the dot plot, which is plot the number for each value of the quantitative variable, I'm going to bin the values of the quantitative variable. In other words, I'm going to create little subintervals of the same length, and I'm going to count how many values are in those subintervals. So here you can see that I have subintervals of length, looks like what, 4 here. Okay, so this is going from 0 to 4. Actually, it's 5. There's 5 data values in here. So these are bins of width 5. And what I'm going to do is I'm just going to count the number of data values in there. All right, so I had 1, 2, 3, 4, 5, 6. There were 6 years or 6 items in my sample for which the number of accidents were between 0 to 5, including 0 and not including 5. That's why we have the closed bracket and the open parentheses there. So that's how we interpret that. Okay, if we then look at the next subinterval of length 5, this says that there were 10 things in our sample, 10 years, where we had between 5 to 10 accidents, not including 10. This looks like a frequency table, like we had for categorical, but it's not. And so this is a problem that people make. And in fact, our book actually calls a histogram a frequency a frequency bar plot, which is plain wrong. And then what I want to do is I want to graphically display that. So I'm going to create these little subintervals, and I'm going to make little rectangles whose height is the number of things in our sample that fall within that range. So I had 6 years where I had between 0 to 5, so I'm going to make my little bar of height 6. So again, it superficially looks like a frequency bar plot, but it's not. And I can put the number over top of each of those bins. And this is how we construct a histogram. So how do we do this in StatCrunch? And this is a little more difficult. And the complexity comes into the bins. By changing where the bins are placed and changing the bin width, you can change the appearance of the histogram considerably. So we're going to start off, first of all, by going to graphs and clicking on histogram, just like we did for the box plot and the dot plot. And now we're going to go ahead again and choose our variable, just like before. So there's a lot of similarities between these commands, right? Now I have to tell StatCrunch whether or not I want to plot the frequency or the relative frequency. And again, just like with categorical variable, it depends a little bit on the sample size, okay? I have a small enough sample here that I could use either one. I only have 31 data values, so I could probably use either one and it would be fine. When we have really large data values, we tend to prefer, again, just like with categorical variables, relative frequencies. Okay, now there are some additional options, and these are actually really nice. The one thing I can do is I can put the values above the bar. And this is really nice when you're reading data because very often it's difficult to look right over and figure out exactly what the value is, especially if you're working with percentages. Counts might not be as bad, but percentages, can you actually tell if a bar is 14.2% high? Of course not. But by putting the value above that, you know how high it is. You can also put markers for the mean and the median, and I generally do that. And we'll discuss later on in the next video when we talk about numerical summaries, why we would want to do that. And then finally, we have our title and our axis labels. So let's go ahead and do that for accidents. So we'll go to StatCrunch now, and we'll do graph, histogram, accidents. I'm going to keep it as frequency, value over bar. I'm going to go down to the markers section and put in the mean and the median. And finally, I'm going to put in a title. Generally, when we're working with quantitative variables, it's good to put the units, okay? And I'll put the same thing I did before. Distribution of F16 Class A accidents from 1986 to 2016. Sometimes people put the source, okay? And so, I might put USAF, and we're ready to go. And this is our plot. And what I want to do is I'd like to compare these three plots. I want you to see how these are three different levels of resolution, if you will. So I'm going to try to fit these all on the same view if I can. And we'll try to put them on the same scale too, so we can make an apples to apples comparison. So the aspect ratio is going to be a little distorted, but that's okay. And what I want to do is I want to kind of impress upon you the different levels of resolution that these plots represent, and also the sort of information they give us. And when we go and study the last section, this will make a little more sense. So these are the three different plots. This is the highest resolution. Every single data value is represented. But you can see it's too much information. Okay. When you have a lot of values for a quantitative variable, or the data sets are really large, dot plots are terrible. Very confusing. I can't make any sense of this. However, when I look at the histogram, it makes a little more sense, right? I can see that there were a decent number of years where I had between 0 to 5, and then the numbers kind of go up in the middle, and then they kind of tail back down like this. This, and when we talk about shape, we're going to talk about this a little bit more. Notice that the histogram kind of shows the same thing. The data is more bunched up on the left-hand end, and you can see that by having this longer tail. Okay, so this long tail in the histogram is reflected by this long whisker right here. So they're kind of complementary views of the same thing. But notice that they're representing very different things. This is showing me the actual distribution of the values. Notice that there's no distribution here. This is just showing me a very rough sort of a very rough sort of way that I can represent the cutoffs, okay? This is telling me 25% of the data lies here. The middle 50% of the data lies here. But it's not giving me this detailed information about the distribution that I'd really like. So this is how we make quantitative plots in StatCrunch. I hope you enjoyed it. In the next video, we're going to talk about what numbers do we want to compute from this variable. They're going to capture important features of this plot. So stay tuned.